This is the first Match 2 online class, especially for the class 10 student of BOSEM Purpose Academy. In the offline class, you have learned the first three exercises of chapter 10, trigonometry, exercise 10.1, 10.2, and 10.3. So we are left with the last exercise, which is 10.4, and the topic of this exercise is height and distance. So before we go further, let's define two terms. The first one is angle of elevation. Here the definition is written for you. It is the angle formed by the line of sight with the horizontal when the point being observed is above the horizontal through the eye. And another definition is angle of depression. It is the angle formed by the line of sight with the horizontal when the point being observed is above the horizontal through the eye. The only difference in two definitions is for angle of elevation you find the word above, and for angle of depression, so it should be below. So this is the only difference you find in the definition of these two terms. Now let's try to understand this definition through a diagram. Here is a diagram for you. Here there is your eyes, or did I say there is the eye of observer. When we look something, here the imaginary line drawn through the eyes, which is horizontal to say the plane or ground. You see here is a horizontal, and now let's say we are looking at a point or at something which is above our eyes. Here is a kite which is flying on the sky, in the sky. Now if you look at this sky which is above our eyes level, which is in the sky, the imaginary line drawn between our eyes and the point that we are observing is called line of sight. And here is a line of horizontal. Then an angle is formed between this horizontal and line of sight. So this angle is called angle of elevation. And for angle of depression, if we look downward, let's say we are looking at a fish which is below the water, that means we have to look downward. So here also an angle is formed which is between horizontal and line of sight. But now in this condition, the point being we are observed, or the point that we are observing is below the horizontal. So the angle formed here is called angle of depression. So further, before we go further, again in this chapter, which is in this exercise, which is height and distance, any structure like building or tower will be considered to be perpendicular to the ground level. Let's say this tower or building, and let's say here is a man standing at some distance from this tower or building. Then the distance between this man and this structure give distance, and the height, by height we means we have to the length, or we can say how tall is this structure, that gives height. So in this exercise, sometime question will ask us to find height, and sometime question will be asking us to find distance. So for most of the question of this exercise, you need to remember only one of the trigonometric ratio. There is tan theta. Tan of angle theta is equal to opposite sides by adjacent side, O by A. And again, just try to remember this at least three angles. Tan 30 degree is 1 by root 3. Tan 45 degree is 1, and tan 60 degree is root 3. So if you understand this, now let's go to the first question. There is a first textual question, exercise 10.4, textual question number 6. The question is, from the top of a lighthouse, the angle of depression of two ships, one directly behind the other, are 45 degree and 30 degree respectively. If the ships are 20 meters apart, find the height of the lighthouse. So for every question of this exercise, first try to understand the question and then represent the question pictorially. That means you have to draw figure. So here is a figure. Here AB represent lighthouse, which is perpendicular to the ground level or horizontal, and here we are given angle of depressions. So here AB represent lighthouse. Here I have written here in the beginning of the solution, let AB represent the lighthouse, C and D be the positions of two ships. Here C and D, let this C and D be the position of two ships which are 200 meters apart from each other. That means the distance between ship at C and ship at D is 200 meters. And we are given two angles of depression because observer is now on top of the lighthouse. So angle of depression are 45 and 30 degree. Since here we have two horizontal which are parallel to each other by applying the theorem that we learned in class 9. If two lines are parallel, alternate angles are equal, then we have this angle 45 and here 30. Not only for this question, but for most of the question of this exercise, for every question we will get two right triangles, and try to get two equations from two right triangles. Here we can see this angle is 45 and this angle is 30 degree, and the distance between ship C and D is 200 meters. So now here you can see two right triangles. The first right triangle we consider is right triangle ABC. ABC. So in this right triangle, now let's write for tan theta. In this triangle ABC, the given angle is angle C, which is 45. So for this angle 45, AV is opposite and BC is adjacent. So we write AV divided by BC, which is opposite divided by adjacent, is equal to tan of angle 45. And you know tan 45 degree value is 1. And from here we get equation AB is equal to BC by cross multiplying. We name this as equation number 1. And now from the first right triangle ABC we get equation number 1. Then now let's consider the second right triangle. The second right triangle is A, B and D, ABD. So again we consider this right triangle ABD. Here too we express in terms of tan. AB is opposite for which angle? For angle 30 degree, and then BD is adjacent. So we write AB by BD, which is equal to tan of 30 degree. AB by AD is equal to, you know, tan 30 degree value is 1 by root 3. So from here again we cross multiply. We express for size AV, which is equal to BD by root 3. We name this as equation number 2. Then now we have to find the height of lighthouse, which is AB. So to find this, you can see in equation number 1, AV is equal to BC. So if we can find BC, then the length of AB will also be that of that BC. So now let's combine the two equations. From equation number 1 and 2 we get, what do you see in the two equations? Here in two equations, equation 1 and 2, we have left hand side AV, AB. Since left hand side are equal, we make right side also equal. BC is equal to BD by root 3. So from here we bring this root 3 from right side to left, then divide becomes in 2, and then right side we write BD. We write BD as BC plus CD. So we write BD as BC plus CD. And again we bring this side BC to left side because we want to write the like terms on the same size. So BC is brought to left hand side and it become minus. Right hand side CD value is 200. CD value is 200 meter. Then from the first and second term of left hand side we take BC common, then here root 3 left and here minus 1. Then we express for BC root 3 minus 1. After transferring to right hand side, it becomes divide. Then now you learn this concept in class 9, rationalization. So we are going to rationalize this denominator root 3 minus 1. To do that, the rationalizing factor of root 3 minus 1 is root 3 plus 1. We multiply the same thing for numerator 2. Then we apply a minus b whole into a plus b is equal to a square minus b square formula. Then we get root 3 square minus 1 square. which is root 3 square is 3 and 1 square is 1, so 3 minus 1 is 2. Then numerator 200 and denominator 2 are cancelled. Then finally we have 100 whole into root 3 plus 1 meter. Why I write meter? Because the distance between two ships is given to be 200 meter. So now we get BC. So we can see from equation number 1, BC and AB are same, equal. So if BC is 100 whole into root 3 plus 1, definitely AB also 100 whole into root 3 plus 1. And what is asked in the question is AB, which is height of the lighthouse. So here finally we conclude that height of the lighthouse is 100 whole into root 3 plus 1 meter. So this is the first textual question we work out. And let's work out the second question too, which is textual question number 8. Again, let's look at the question. Question number 8. Two men on opposite sides of a temple 75 meter high observe the angles of elevation of the top of the temple to be 30 degree and 60 degree respectively. Find the distance between the two men. So repeat reading question 2-3 times until you have the full knowledge of the question. Then here after that you try to draw figure. Now we take AB to be the temple, which is 70 meter high. And now two men are on opposite sides of the temple, so we take C and D, which are on opposite sides of AB, to be the position of two men. Let AB represent the temple. AB is temple. C and D be the position of two men on the opposite sides of AB. C, position of one man. D, position of the second man. Now question is, find the distance between the two men. Now if you look at the figure, C and D are the position of two men, so their distance is CD. To find CD, we should know BC and also BD. If you have the length BC and BD, adding them together we get CD, which gives the distance between two men. So it's just like what you have seen in the first question. Here too, we will consider two right triangles, and from two right triangles we'll try to get two equations. Now first let's consider the right triangle ABC. Right triangle ABC. Here angle C is 60 degree. So for angle C, which is 60 degree, AB is opposite side and BC is adjacent side. So we write AB by BC, which is opposite by adjacent, is equal to tan of 60 degree. And tan 60 degree value is root 3 and AV value is 75, so cross multiplying we get BC is equal to 75 by root 3, and we name this as equation number 1. Again we consider another right triangle, which is ABD. For this right triangle we have angle D, which is 30 degree. So for this angle D 30 degree, AB is opposite and BD is adjacent. So again we write in terms of for this tan theta in right triangle ABD, AB, which is opposite, by BD adjacent, is equal to tan of 30 degree. Tan 30 degree value is 1 by root 3, and again we replace AB by its value 75. So cross multiplying we get BD is equal to 75 root 3, and we name this as second equation. Now you can see first equation we have BC, second equation we have the value of BD. So if you look at the figure, BC and BD, simply we need to add them together to get CD length, which will give the distance between two men. So we add the equation 1 and 2, we get equation 1 BC and equation 2 BD. We add them, and then from the figure BC plus BD, BC plus BD is nothing but CD. And here to add these two we take LCM root 3, we divide LCM by denominator root 3, 1 into numerator 75, we get 75, plus here you can see denominator is 1. So divide root 3 by denominator 1, we get root 3. Root 3 into 75 root 3. Here I have written in rough column. 75 root 3 into root 3. Root 3 into root 3 is 3. So 75 into 3 is 225. And in the next step, we add 225 and 75, which is 300. 300 divided by root 3. So now you can see denominator root 3 is irrational number. So let's rationalize it. To rationalize this denominator, we need to multiply by another root 3, so that root 3 becomes 3, which is a rational number. So multiplying denominator by root 3 and also numerator by root 3, we get 300 root 3 by 3. Again, you can cancel here, divide 300 by 3, we get 100 root 3 meter. And again, this is nothing but this is the value of CD. And if you go back to the figure, CD is nothing but the distance between two men, because C and D are the position of two men. Thus, distance between the two men is 100 root 3 meter. So, there is the second question. Now, I will give you some question to practice as homework, your assignment. Question number 6, 7 and question number 18. I'm talking about textual question. Exercise 10.4. Question number 7 and number 18. They are similar to question number 6, the first question. And question number 14 is similar to the question that we just finished now. That is question number 8. So first learn these first two questions which we have completed now. You can repeat watching the video again and again and practice these three questions as your homework or home assignment. Thank you.